Today in this class, basically we will cover two methods for solving the ordinary differential equation using the numerical way. Now, which two methods are in our regular classes? We have covered two multi-step methods. One was the Euler method and another was the Arche method. Now, today we discuss one multi-step method for finding the solution of initial value problem of ODE and another finite difference method for finding the solution of the boundary value problem. So we start with the multi-step method, which is called we have many multi-step methods, but here we will just focus on the Milne's predictor corrector method. So this is another multi-step method for solving ODE. Which type of ODE? Now, initial value problem of ODE, ordinary differential equation, where the initial conditions will be given. And why we are saying these methods are multi-step method? There are so many multi-step methods like Euler's predictor corrector method, predictor corrector method. Next, you will get the Milne's predictor corrector method, and then we have also Adam-Basford-Moulton method, Adam-Basford, I think F-O-R-T-H and M-O-U-L-T-O-N. It is also a predictor corrector method. Now, other methods are also there, but we are not going to all this. Like Adam-Basford method is also there. But basically, what we do here, there will be two formulas, one for predicting the next values and another for correcting the next values. And why these methods are called the multi-step method? Because if I say you the Milne's predictor corrector method, if we just focus on this, so one ODE will be given, like dy dx is equal to some f of xy is given with the condition, suppose y of 0 is equal to 1. Now, in this multi-step method, some of the other values will be also given. So, this one value is not only sufficient to operate a multi-step method, because to find the next value, we will use many previous values. Many means, like in the Euler's predictor corrector method, you will see that for the corrector part, it will use two values together. In Milne's predictor corrector method, at a time, it will use four previous values. So that's why we need some more values here for the ODE. But this is our y dash. So y dash is a function of xy. Now I am not writing the conditions. Some of the condition you will get here. And what we have to find? We have to find the y values. What are the y values corresponding to the x values? So this is our aim. So if we just focus on the Milne's predictor corrector, which is in your syllabus, Milne's predictor corrector method, what we will do here? What is the formula here? Milne's predictor corrector. These are two parts, and you have to remember these two formula. First, the predictor part or the predictor formula. What it is saying? Predictor formula is saying that yn plus 1 value is approximately y of n minus 3 plus 4 by 3h into 2y n minus 2 dash minus y of n minus 1 dash and plus 2y of n dash. So this is the predictor formula. Now you can just realize that this is not a very easy formula, and also you have to remember this, and remembering this is also not a very easy job. But this is the predictor formula, and in this predictor formula, basically when we apply From which value it will start? Obviously, the starting value should be what? N is equal to 3. Why? So this is the starting value. So starting with n equal to 3, this formula will work. Why I am saying that? Because if you take n equal to 2, suppose if you take less than 3 values, then you will get y minus 1 values there. And as you all know that our y values is starting from 0. y0, y1, y2, y3. In indices, we are not giving the negative indices. So that means first we will start with n equal to 3. And what formula you will get here? So we will get, if we put n equal to 3 in this equation, what we are getting? y3 plus 1 equal to y4 is approximately y3 minus 3, which is y0, then plus 4 by 3h into 2y, 3 minus 2 is 1, y1 dash, minus y of 2 dash, plus 2y of 3. Now I think you have already realized that to find y4, it is using 4 previous levels like 0 level, 1 level, 2 level and 3 level value. That means before finding y4, you need to know all these values. What is y0, what is y1, what is y2 and what is y3. Otherwise, this Milne's predictor corrector method will not work. That means to start a multi-stream method, you have to go through the single stream method. Like you are using RK method, and suppose in this problem only the y0 is given, like y0 value is 1 given, or y of some x0 is equal to y0, initial value is given. Now you know the y0. Now you are applying the RK method. Now using RK, by using y0 you can find y1. Then by using y1 you can find what? y2. Then using y2 you can find y3. Now you able to apply the Milne's predictor corrector method, not before that. So by using the single step method, you have already found the y0, y1, y2 and y3. Now just use it to find the predictor formula. So using predictor formula, you will get the y4. And I am writing it as y4p. So this is y4 predicted. Now till now, tell me, is it clear or not? We will come to the problem. But up to that, is it clear? But you have to remember it. No other way is there. Up to that, is it clear? Otherwise, we will go to the corrector formula. Now,
Yes, sir.
writing the corrector formula, and what is the corrector formula here? It is also you have to remember. One thing, how to calculate this yn dash, how to calculate this yn minus 1 dash, how to calculate this yn minus 2 dash, how you will get all these values. Because you know that in the given ODE, y dash is given as f of xy. That means if you have to find y n minus 2 prime, it is actually f of xn minus 2 comma what? Yn minus 2. Because y prime is f of xy. So at the point n minus 2, the value is f of xn minus 2 comma yn minus 2. Similarly, y of n minus 1 prime is f of xn minus 1 comma yn minus 1. That means at that point the functional values. Similarly, yn prime is equal to f of xn comma yn. So in this way, you will get all these values. After that, just you have to put all these values and you will get the prediction values. And that means the predicted value of y4 at the starting. So I am writing it as yn plus 1p. It is the predicted. Now the corrector values. So now the corrector formula is yn plus 1. The same value will be corrected. So I am writing the c. C means the corrected value. So yn plus 1c is equivalent, actually is approximately equal to yn minus 1 plus 1 by 3h into y of n plus 1 predicted dash, or dash value as the point predicted. You can write it like this. Understood it clearly. Yn plus y dash t. What it means? That means at the predicted point, what is the value of yn plus 1 dash? So how you will calculate it? You have to calculate it by yn plus 1 prime. I'm writing it here. Where this yn plus 1 prime predicted point is f of at the point xn plus 1 and yn plus 1 predicted value. Previously, you have used the yn plus 1 values, but here instead of yn plus 1 we will use the predicted value of the yn plus 1. So this is yn plus 1 dash predicted, then plus 4 into yn dash plus y of n minus 1 dash. So this is the formula, whereas you have already this yn prime formula and yn minus 1 formula from this above part. These two are same. These two are same in the prediction formula and the correction formula. So only the difference here you will get a new term yn plus 1 value at the predicted point you have to include it. That means now how many points the corrector value is actually taking? So if I start with the n equal to 3 and if we prepare the corrector formula, how it looks like? Corrector formula को ready करो. So y4c corrector will be put n equal to 3. So that means y of 3 minus 1 y2 plus h by 3 into y of 4 dash at the predicted point plus 4 into y3 prime plus y2 prime. Now you can see the corrector value at the fourth level is calculated using the 2 level, 3 level and the fourth level value itself. That means for correction value it is using 3 previous values. For predicted values it is using 4 previous values. That's why these methods are called multi-step method. So different method uses different number of previous values but not one values. All these multi-step method we use more than one values to predict the previous values. But one thing it is very clear from here that no other way is there except remembering this formula. So you have to remember the formula. Now find a way how you can remember the formula. So just by writing the formula you will get the step marks. বলো
স্যার বলছি এই কারেক্টর ফর্মুলাতে নিচে যেখানেতে y ড্যাশ p টা বললেন ওটা আরেকবার বলবেন?
y dash p. Actually yn plus 1 dash p is the yn plus 1 dash value at the predicted point. So if I write it like this, so it is yn plus 1 dash value at the xn plus 1 comma yn plus 1 predicted point at here, at this point. Clear? That means xn plus 1. Previously what you have seen, the yn dash is actually f of xn comma what? Yn. That is na? Yn dash is f of xn comma yn. But here yn plus 1 dash p is the yn plus 1 dash value at the xn plus 1 comma yn plus p value, p point. That means instead of yn plus 1, actually we don't have the yn plus 1. This is our aim. We are aiming to calculate yn plus 1. এটাই তো খুঁজছি. But we don't have the exact value. We have the predicted values. So that's why we will put the predicted value here. And to differentiate it, that what value we are putting, this notation is given here. That means p means the predicted value we will put here. Most of the books will not use this p or c notation. Most of the books will not use it. But the problem is, in this way, finally you will not understood which value should take where. What is the predicted value, what is the corrected value. So just to distinguish these two values, we are using p to determine the predicted and c to note that this is the corrected. So this has no effect except the notation. This is just the notation. So when I am writing p in the top, it means that we are finding this yn plus 1 dash value at the predicted points, যেটা আগে আমরা পেয়েছি from the using the prediction formula. বলো, is it clear?
হ্যাঁ স্যার।
Now we will do one math, then it will be more clear. But basically understood one thing, here we need previous 4 values to go to the next values. So in question, all the values will be given. You don't have to calculate it using the RK method. That is our real time method. But in exam, all the four required previous value will be given. So I am writing on questions here and now just follow it. So the question will be like that. So given that, given that dy dx is equal to 1 plus xy. So I think you have already found what is the f of xy. Where y0 value is equal to 2, y 0.1 value is equal to 2.1103, y at the point 0.2 is equal to 2.2430, y at the point 0.3 is equal to 2.4011. So these all values are given. That means the required four previous values are given. It is y0, it is y1, it is y2 and it is y3. All the four values are given. Now find the next value. Find y at the point 0.4, that is y4 you have to find by Milne's predictor corrector method. Milne's predictor corrector method. Predictor corrector method. This type of maths are very easy. Basically, you will get 7 to 8 marks in this type of problem, but these are very easy math if you remember the formula. Otherwise, formula you can do it. So first of all, what we will note down from here, whatever the available values are there, we will note down it. So available values are dy dx is equal to 1 plus xy, and which is our f of xy. Na? This is our f of xy. So, and this dy dx actually y dash or the y prime. So y prime is actually 1 plus xy, which is f of xy. And what is x0 here? Can you tell me? X0 is 0. Na? X1 is 0.1, X2 is 0.2, X3 is 0.3 and X4 is 0.4. Now Y0 value is given as 2, Y1 value at 0.1 value is 2.1103, Y2 value is 2.2430, Y3 value is equal to 2.4011 and y4 value is our target. We will find it. We need the y4 because we need the y value at the point 0.4 and this 0.4 is your x4. Now, if in question they ask you for y of 0.5, that means 2 times Milne's predictor corrector method. First you have to find 0.4, then you have to go to 0.5, and such type of problem will not come in your exam. So in exam you will get just in one step. That means 4 previous value will be given and you have to go to the next step. So this type of problem will come in your exam. So now how to start it? First write the Milne's predictor formula. And okay, one more value we need. What is the value of age? Tell me, what is the value of age here? Can you identify what is age?
0.1.
Yes, 0.1. That is the step length which you can find in X. So now the Milne's predictor formula. Milne's predictor formula. What is the Milne's predictor formula? Yn plus 1 is approximately y of n minus 3 plus 4 by 3 age into 2yn minus 2 prime minus y of n minus y prime plus 2y of n prime. Now in this predictor formula, we will put, so putting n equal to 3, we get, in this formula, we will get n equal to 3. So we are getting the formula as y4 is approximately y0 plus 4h by 3 2y1 prime minus y2 prime plus 2y3 prime. Now 1 by 1 you have to find all those values. So what value you know? Y0 we know. Na? Y0 is known value. We know that value Y0. Here the Y0 value is given. We know the age value. This is a known value. Y1 prime, we don't know that value. So we have to find it. So find the Y1 prime value. So what is Y1 prime? Tell me, what is Y1 prime? It is F. So Y prime is F of XY. Now Y1 prime is the f of x1 comma what? y1. F value at the point x1 y1. Now what is f of x1 y1? 1 plus x1 y1. So 1 plus x1 value is 0.1 into y1 value is 2.1103. Now if you multiply and add it, what value you will get? 1.21103. Okay, now tell me, is it clear or not? Is that step clear? Y1 prime value. Similarly, calculate y2 prime. Y2 prime is f of x2 comma y2, which is similarly 1 plus x2 y2. That means 1 plus x2 value is 0.2 into y2 value is 2.2430. Now using these two, if you multiply it, so this is 4486 and 1.4486. This is the value y2 prime. Similarly, calculate y3 prime. Y3 prime is f of x3 comma y3, which is 1 plus x3 y3, and value is 1 plus x3 value was 0.3 and into y3 value was 2.4011. 2.4011. So if you multiply it, so this is 3 and then 3 0, then 24 3 72. That means 271 point. So 1.72033. Now these are the y1 prime, y2 prime and y3 prime value. Now put all these values here. You will get the y4 predicted value. So I am writing as P. P means the prediction. So y4 predicted values is approximately equal to y0. Y0 value is equal to what is y0? Y0 is 2. You can see it from here. Y0 equal to 2 plus 4 into age is 0.1 divided by 3 into 2 into y1 prime value is 1.21103, then minus y2 prime is 1.4486 plus 2 into 1.72033. All these values we have given here, and if you calculate it, is anyone have calculator? Okay, now if anyone have calculator in their hand, you can calculate it and give me the value.
2.5885.
2.5885. Okay, so these are our predicted values. So prediction part is over. Now we will go for the corrector part. So now Milne's corrector formula. Milne's corrector formula. Corrector formula. Now what is the Milne's corrector formula? So we have already written. Just by writing the formula you will get the step marks here. Formula was yn plus 1. So in each year I have seen these questions, so you can also find it from the PYQs. But so if you can remember it, just go to the exam and at the starting write it in your answer script. Okay, if you think that you will forget it, but definitely it will help you, because if you know the formula, nothing else you need to do the math. Only formula is needed. Other things are very easy. So now yn plus 1 corrector value. So I am writing C. This C is not any complement, any other thing. This C implies that this is the correction formula, nothing else. So yn plus 1C is equal to yn minus 1 plus h by 3 into y of n plus 1 dash at the prediction point. So this P indicates that at the predicted point we will find it, plus 4y of n prime plus y of n minus 1 prime. Okay, this is the formula. Clear? Now in the same formula put n equal to 3. Similarly the same method here we will apply. So putting n equal to 3. Putting n equal to 3, what we are getting here? Y4 correction value, that is y2 then plus h by 3 into y4 dash at the predicted point plus 4 into y3 prime plus y2 prime. Now y3 prime, y2 prime, the both values already we have. We have already finded this y3 prime here. We have this value. y2 prime we have already this value. And y2 we already have. from the question, y2 is already given here. This is y2. Now, only thing you have to calculate for the corrector formula is y4 prime value at the predicted point. So, just calculate it. Y4 prime at the predicted point is the f value at the point where x4, comma y4 predicted point, and y4p, the value what just you have calculated here. So that is your y4p. You have just calculated using the prediction formula. So now we will use it to find the y4 dash prediction value. So which is 1 plus x4 into y4p. So 1 plus x4 value is 0.4 into y4 prediction value is 2.5885. Now multiply it and tell me the value what you are getting. What y4 prime p you are getting?
2.0354.
2.0354. Okay. Now, so we have all the values. Again, put all these values. So y2 value was, where was y2? 2.2430. 2.2430. Then plus age is 0.1 by 3. Y4 prime dash p is 2.0354 plus 4 into y3 prime was 1.72033 plus y2 prime was 1.4486. Now we have all the values. Now calculate it and give me the values.
এটাও তো সেম আসছে 2.588510
5885. সেটাই তো 2.5885. That means we are getting the prediction value and the corrector value same, but it is not necessary that the prediction and the correction value will be same. You can get different
আচ্ছা
values.
এখানে তো এই অ্যাপ্রক্সিমেট ইকুয়ালস টু থাকবে না ইকুয়ালস টু দিয়েছেন
Obviously approximate. This value is not equal. All these values are actually approximate values. We are in numerical, whatever we are getting y4p, y4c, these are approximate solution of the ODE. These are not the exact solution of ODE. So it is a best practice if you use the approximate sign in the solution. But sometimes we forget and it does not matter. Your teacher will not reduce your marks for that reason. So y4c, now one thing remember, suppose in y4 prediction you are getting 2.5885 and when you are calculating y4c you have got suppose 2.5887, you have got this value. These two may different. I am not saying that these two value will be always same. This value can differ from the y4 predicted value, but your answer will be the value that you are getting in the correction value. That means this corrector value will be your answer. Whatever you are getting, this will be your answer. It may be different from the prediction value. It may be same with the predicted value, but your answer will be the corrector value, not the prediction value. Okay. So hence the required value, of y 0.4 is equal to 2.5885. Always remember this value will be the value from the corrector formula. Value from the corrector formula. No matter is it same or not same, your answer will be the value which you are getting from the corrector formula. Is it clear? Now, if your function is complicated, then you may get problem in your calculation. Till now your function was a linear function, so that's why it's not a very difficult thing. But suppose instead of 1 plus xy, if the problem comes with dy dx is equal to x plus y by x minus y, in that case, in each and every step you have to deal with this type of function. And it may be complicated in calculation, nothing else, but you can deal with that. This problem is very simple and procedure will be same as it is, which can be changed. The functional value can be changed. Function can be changed and the values can be changed, not any other thing. So just whatever the fxy function is given, you have to find it multiple times using calculation like this.